All right, let's dive into something pretty wild. We're going to look at this incredible analysis that lays out how one single choke point, just a tiny strip of water, could literally set off a chain reaction that brings down our entire global system. And no, this isn't some movie plot. It's a very real look at just how fragile our modern world might be.
And this quote from the analysis we're digging into, it just hits the nail on the head. The whole idea is that in our rush to make everything super efficient, we've accidentally built this incredibly dependent machine. It's so connected that if one little piece breaks, the whole thing could just fall apart.
So, how does this all happen? We're going to walk through it in 4 stages. First, we'll look at the choke point itself. Then, we'll see how that impacts everything from fuel to factories. After that, we'll see how the digital world gets unplugged. And finally, what all of this means for civilization as we know it.
Okay, so first up, the ultimate choke point. Let's talk about where this whole potential collapse kicks off. It all starts at the epicenter, this one narrow channel of water called the Strait of Hormuz.
Yup, it all starts right here. A shipping lane that's only 21 miles wide. I mean, think about that. This single tiny passage basically has a monopoly on the entire world's energy economy. It's kind of crazy. And the amount of stuff that has to squeeze through here is just staggering. We're talking about a fifth of all the oil the world uses every single day, plus a fifth of all the LNG, that's liquefied natural gas, that gets traded. All of it has to go through this one little spot. That is a huge amount of risk concentrated in one place. Now, you're probably thinking, well, what about pipelines? Can't we just bypass it? Good question. But the numbers just don't work. The analysis shows that all the other routes combined can only handle a tiny fraction of what gets blocked. So you'd be looking at an immediate global shortfall of more than 17 million barrels of oil every single day. There's just no way to make up for that. Okay, so that fuel blockage, that's just the first domino to fall. Now we get to the really interesting part, how this one problem spirals into a massive industrial crisis. And trust me, the connections here are probably not what you'd expect. So, here's the key thing to understand. Most of the oil that comes from this region is something called sour crude. All that really means is it has a lot of sulfur in it. And when refineries process that oil to make gasoline and other fuels, they get sulfur as a byproduct, whether they want it or not. And it turns out that unwanted sulfur is the secret ingredient for, well, almost all of modern industry. And here's how that domino chain works. You block the sour crude, you lose the sulfur. You lose the sulfur, you can't make sulfuric acid. And why does that matter? Well, without sulfuric acid, you can't mine for things like copper and cobalt, especially in places like Africa. Suddenly, all the metals we desperately need for batteries and wiring, they just stop coming. It's the exact same story, but for our food. You see, a ton of natural gas also comes through that strait. And that natural gas is what you need to make ammonia, which is the key ingredient in modern fertilizers. So you block the gas, you stop making fertilizer, and the analysis says that within just one planting season, you're looking at a global food crisis. It's that direct. Okay, so we've got industrial chaos, we've got a food crisis, but what about the digital world? You know, the internet, AI, the cloud. That stuff's safe, right? It just floats around in the air. Well, the reality this analysis points to is not so simple. In fact, it's incredibly fragile. Yeah, we have this idea, don't we, that our digital lives are just weightless, that the cloud is literally a cloud, completely separate from the grubby physical world of ships and oil and chemicals. But the truth is, it's a direct physical chain, and it is brutally simple. You need ships to deliver that liquefied natural gas, you need that LNG to provide super stable power to the electrical grid, and you need that perfectly stable grid to run the factories, the fabs that make all our computer chips. No ships, no LNG, no LNG, no stable power, no stable power, no chips. No chips, no data centers, no AI, no cloud. Period. And get this number is absolutely critical. Taiwan, which makes pretty much all of the most advanced computer chips in the world, only has an 11-day supply of LNG in reserve. That's it. So a blockade would mean they'd have to start rationing power almost immediately. And for chip making, even the tiniest dip in voltage for a microsecond can destroy an entire batch of chips worth millions of dollars.
But even if, by some miracle, you could get the chips, you run into another huge problem. The physical hardware you need to actually use them, we're talking about the massive power transformers for data centers, is already in a crazy bottleneck. The analysis points out that the wait time for some of these parts is already over 4 years long.
And just look at the scale of this problem before our crisis even starts. Right now, in the US alone, there's a backlog of energy projects big enough to power entire countries, all stuck waiting for hardware. Now, you throw in that copper shortage we talked about earlier, that whole pipeline just freezes solid. Say goodbye to the energy transition, say goodbye to the AI boom. So, we've got factories shutting down, the digital world is unplugging. What happens when all of this finally trickles down to our daily lives? Well, that brings us to the final and most devastating stage, a true crisis of civilization. This is where money itself starts to break down. The analysis makes a powerful point. When you can't get the physical things you need, food, fuel, parts, money starts to become meaningless. That's what hyperinflation really is. It's not just numbers on a screen. It's the social fallout from real-world shortages. And when that happens, nobody, not you, not companies, not governments, can plan for tomorrow.
And what's really terrifying is how fast this all happens. This timeline just lays it out. Within 2 weeks, you have gridlock at sea. Within a month or two, you're in a chemical famine. Within a year, the hardware and grid crisis is in full swing. And within just a couple of years, you're seeing countries go bankrupt and a total shift in global power. It unravels fast.
So the endgame here isn't just a bad recession. It's a complete rewrite of how the world works. The analysis paints a picture of a new reality. Widespread blackouts, food shortages, countries defaulting on their debt, basically going bankrupt. And global cooperation, that's gone. It's replaced by a scramble for resources, where security is all that matters, not efficiency. And that really brings us back to the central idea of this whole analysis. These supply chains, they aren't just about moving stuff around. They're like the hidden beams and pillars holding up the entire structure of our society. They are the invisible architecture of social peace. You know, for decades, we've built this incredible global system based on just-in-time efficiency. No waste, no extra inventory, everything optimized for cost and speed. And honestly, it's a masterpiece of logistics. It truly is a marvel. But this whole scenario forces us to ask a really tough question. What if that incredible efficiency is also our greatest weakness? In our obsession with making everything so lean and optimized, have we accidentally created a system so brittle that its greatest strength is actually its fatal flaw?